Lesson 5.2. Evaluate and graph polynomial functions. Large branches of mathematics spend all their time dealing with polynomials, because polynomials can be used to model many complicated systems. A polynomial in one variable is a function that has one variable, and there are powers of that variable, and all the powers are positive. For example, this is a polynomial in one variable. One variable is x, and there are various exponents, positive exponents, on the x's. This is also a polynomial in one variable. The only variable is x, and all the exponents are positive. This is not a polynomial in one variable. It does only have one variable, but the exponent on the x, if we wrote it in a single line, would be -1. This is also not a polynomial in one variable because there are two variables, x and y. Degree is the highest power of the variable. So what is the degree of this polynomial expression? Well, if we look, the highest exponent is 3. So the degree is 3. There are different types of polynomial functions based on their degree. So we have degree and the type. So degree 0 is called constant, like y equals 2. And it gives you a horizontal line. Degree of 1 is linear, like y equals 2x plus 1, and it gives you a line, hence the name liner. Degree of 2 is quadratic and gives you a parabola. Degree of 3 is cubic, you can see that shape. Degree of 4 is quartic, and it looks kind of like a parabola, only the bottom is flatter. A function f of x equals all that stuff means that the polynomial has the name f and the variable x. Name f, variable x. We name functions this way so that we can have a whole long list of functions and we can tell which one we're talking about. We can have function f and g and h and so on. And then the x just tells us what variables we have or what value we've plugged in. F of x does not mean f times x. F of x is one thing, it is the name of the function. If we need to find like f of 3, notice the x in f of x was replaced by a 3. So you replace all the x's with 3 in the polynomial. So here's our polynomial function. To find f of 3, replace all the x's with 3's. Then simplify. 3 cubed is 27. 3 squared is 9. 2 times 3 is 6. Combine all that, you get 137. So f of 3 is 137. Notice this is not f times 3 equals 137. This means function f with input of 3 gives us 137. So if I plug a 3 into function f, we get 137. There is a quicker method to plugging things in. It's called synthetic substitution. So let's say we want to find f of 2, and this is our function, f of y, or y is our variable. Now, notice we were missing some exponents on the y. Up here we had y to the 6th, but no y to the 5th. We have y to the 4th, but no y cubed. And we end with a y. We don't have a constant term. So we need to fill those in if we're going to use synthetic substitution. So we added a 0y to the 5th, a 0y cubed, and a 0 constant term. The number we're substituting in goes there with a box around it. And then you put all the coefficients, including the placeholder zeros. So it's the -1 y to the 6th. It's 0y to the 5th. It is 4y to the 4th. 0y cubed, 3y squared, 2y, and 0. Draw a line. And the first thing that happens is the first number goes straight down. Technically, we're adding it to 0. So -1 becomes -1. Then we multiply the number in the box with that number. So we go 2 times -1 is -2. Then we add down. So 0 plus -2 is -2. And then we multiply 2 times -2 is -4. Then we add down. 4 plus -4 is 0. Then we multiply 2 times 0 is 0. Then we add down. 0 plus 0 is 0. Then we multiply 2 times 0 is 0. Then we add down. 0 plus 3 is 3. Then we multiply 2 times 3 is 6. Then we add 2 plus 6 is 8. And then multiply, get 16. And 0 plus 16 is 16. We put a box around the last number, and that is our answer. So f of 2 is 16. If you take a 2 and plug it into the function, you get 16. We also need to talk about end behavior. A polynomial function always goes towards infinity or negative infinity, that means up or down, at either end of the graph. If there's an even degree with a positive leading coefficient, both ends go up. If we have an even degree with a negative leading coefficient, both ends go down. If we have an odd degree with a positive leading coefficient, the left side goes down, the right side goes up. And an odd degree with a negative leading coefficient, the left side goes up, the right side goes down. So how we write it out is using this sentence. Only thing we replace is the underlined portion. So what this is saying is f of x, that's y, so y goes to positive infinity as x goes to negative. So that means on the left side, the negative side, the y values are going up. And this says the y values are going up as x goes positive. So that's to the right. So this is saying on the right side, y is going up. So that is this first one, even degree positive leading coefficient. On the left it's going up, on the right it's going up. So we have positive infinity there, positive infinity there. If we were doing the odd degree with positive leading coefficient, the left side would be going down, so this would be a negative infinity right there. The right side's going up, so this would stay positive infinity. Graphing polynomial functions. To do that, you make a table of values. Easiest way is on a calculator. You plot all the points, and then make sure your graph matches the appropriate end behavior. So let's graph this polynomial function. The end behavior, the degree is odd. The degree is 3, which is odd, and we have a positive leading coefficient. That means that on the left side, it's going down, and on the right side, it's going up. Let's make a table of values. Ta-da! Used a calculator to make a table of values. Plot all the points that fit on my graph. So that was this point, that point, that point, that point. And draw a curve that's going to go through. So we start from the left, it's going to come up from the bottom, go through the points, looks like it's going to have to go down here, then back up, and it's supposed to be going up on the right. And it looks like that. Make sure it matches the in behavior. We said it's going down on the left, up on the right. And that's all for today. Have a good day.